In this lesson, we will discuss chapter number 3 integration exercise 3.4 question number 1 part 10 and question we have integral of x tan inverse x dx. So see here in this question we have the inverse trigonometric function, and I have told you if we have an inverse trigonometric function, then we have to consider it as a u first function. It means we have to take the derivative of this function. Why we are taking tan inverse x as a u? Because when we will take the derivative of this function, we will get the algebraic expression. I will show you, and this x we will consider as a v, means for this we have to do the integration, for u we have to take the derivative. And again this exercise we are using by parts, and the formula we are using integral of v dx, which is equal to u integral of v dx minus double integral of v dx d by dx of the first function, which is u and dx. So wherever in this formula we have u, we have to write down tan inverse x, and wherever we will see v, we have to write down x. So see, first is the u, and u is tan inverse. This is the first function, tan inverse x integral of x dx minus integral of same x dx and d by dx of u, and u we have tan inverse x dx. So see, this tan inverse x will remains the same. For this, right, we will use the power rule, and power rule is we have 1 power of x we will add, so I will do it directly because we have solved too many questions related to power rule. Minus 1 integral will remain the same. For this integration it is same x square over 2 d by dx. So tan inverse x, right, which is equal to 1, or I will write down 1 divided by 1 plus x square dx. I have told you that why we are considering this as a first function, because we have to take the derivative, and the derivative of tan inverse x is 1 divided by 1 plus x square. This is the algebraic expression. So here tan inverse x, because they are multiplying each other, we can write down like this, minus this 2 is constant, so we can take out from the integral sign. We have x square divided by 1 plus x square dx. So see what we have to do here. This is the fraction, and I told you, right, that if we have the same power of the variable in the numerator or greater power compared to the denominator, we have to reduce the power of the numerator, because this is not the derivative, right? X square, the derivative of 1 plus x square should be 2x, but we have x square. So how we will reduce? One more time, if the powers of the variables are equal, or the power is of the numerator is greater than the denominator, then we have to reduce. How? I will show you here. X square, this numerator you have to make as a dividend, 1 plus x square. So here will be x square plus 1, and then minus minus, here will be minus. So now we have 1 minus 1 over 1 plus x square, right? So same, this portion I will write down same. For this I will show you here. It is x square divided by 2 tan inverse x, right, minus 1 over 2, and then integral of 1 minus 1, this one. You have to start from here. 1 minus 1 divided by 1 plus x square. Now these we have two terms, so we will do the separate integration. This part will remains the same. Here we have minus. 1 over 2, and this 1 over 2, 1 dx is related to this and this as well. So that is why we will use the bracket integral of 1 plus x square dx. So it is x square over 2 tan inverse x minus 1 over 2, right? For this 1 dx, the integration is x, and then minus c, 1 divided by 1 plus x square. So we do not have a variable here, but it should be 2x here, because the derivative of 1 plus x square equal to 2x. Or sorry, we are not going to take the derivative. So 1, there is another formula we will use, because 1 divided by 1 plus x square should be, its the integration is tan inverse. So it is tan inverse x plus c. Now we are going to multiply, so it will be x square over 2 minus 1 minus x over 2 minus 1 over 2 tan inverse x plus c. This is the answer, right? Still you have any question? Without any hesitation, you can ask me, and thanks for watching.